So I'm not sure if this is the best time slot right before lunch, but hopefully it'll be a good time. I think it's going to be a fun talk. It's test driving, streaming, and CEP, complex event processing on Apache Ignite. So welcome. Thanks for being here. All right, my name is Matt Covington. I work for a company called Innovative Software Engineering. We're based in the Midwest in Iowa, close to the University of Iowa, if you're familiar with them. I lead our big data services solutions. I'm also part of our innovation team, so we kind of have a business unit that does innovation, proof of concept work for our customers. And basically what we do, we're a professional services firm. We're very focused on vehicle telematics, big data, mobile applications. That's kind of our areas of focus and of interest. Vehicle telematics, if you don't know, I mean, it's basically applications of IoT in vehicles. So it can be anything on a car, on a commercial truck, on farming equipment, on construction equipment. So we do a lot of those types of things. So it's really more of a specific use cases for IoT. There's our website. There's my email address. I've been at ISC for 10 years. I've worked in enterprise systems for 15, large-scale enterprise systems for 15 years. Love my job, love my place of work. We have a great culture, really enjoy it. So I'm going to talk about Apache Ignite, streaming, and CEP. How many were in here for the previous talk with Nikita? Okay, awesome. So I'm not going to overlap anything, but it's great that you guys were here because he did a lot of talking about some things about Apache Ignite and just general things about the data grid and compute grid and things like that are going to be good context for you guys that were in here in the past previous talk there. When we get into this streaming and CEP, we'll try and position it in the context of where that functions in Apache Ignite. And then we'll get to the fun part, was actually show you some code of how this works in Apache Ignite. So, sound good? All right. So one thing that's really important, believe it or not, so come in and say, well, what is streaming? Well, I think we know what streaming is. Let's move to the next slide, Matt. But it's really good just to baseline this, and I really want to baseline us on this idea that you got to think of streaming, really take that word out of your head, just kind of we did with big data. We have big data and fast data and lots of different terms, and let's really define that term. And what streaming is really all about is processing unbounded data streams, right? So let's think about it in those terms. And if you, and maybe you have a different execution engine, like you might have Spark as an execution engine, or Flink, or Apex, or in this case, Apache Ignite as your execution engine for streaming. But there's design patterns and ways of thinking of how you process this data that are common across all the execution engines, or we would want them to be common across all the execution engines. And really, you can think about it as at an architectural level. And this is why I wanted to kind of recommend to you, if you haven't read these two articles here, The World Beyond Batch. These two really put out a really good patterns and ways of thinking about unbounded data sets that I think if you're into streaming, you should read those, really, and they'll be really helpful for you. It's also, so that was kind of in a sense of an announcement as well. They went. This was a guy from Google. Are you guys familiar with Google Data Flow? Anybody use Google Data Flow? No? Yeah, a couple people. So they took their SDK for Google Data Flow and open sourced that, and that's become Apache Beam. And Apache Beam's intent is to become an API for streaming. So they're working on bindings, if you will, to Spark, to Apache Flink, and then, of course, Google Data Flow, which is their in the cloud service for streaming that Google has. So you could basically write a pipeline in Beam, and this is all initial stages, so I don't think you can really just go out there and do that now, but you can write the pipeline in Beam and then run it on Spark, or you could run it on Flink, or you could run it on Google Data Flow. Maybe someday you'll run it on Ignite, right? You can choose your execution engine, but have the same pipeline using the same API. So that was just a little bit about streaming. Complex event processing is a little bit different, right? So when you're doing complex event processing, you're not just thinking about a particular stream of data, you're actually thinking about combining streams, if you will, or combining data sets that maybe arrive at different times, different frequencies, and you want to find some sort of pattern within that data, and you want to trigger maybe a little bit of higher logic, if you will, based on those circumstances. So this is an area where, if you think about the cross-cache joins and the various capabilities that Ignite offers for querying, where complex event processing really shows up as a strength for Apache Ignite. So if we think about streaming now in the context of Apache Ignite, Nikita Ivanov brought up this same diagram here, and I've just kind of highlighted actually with some arrows where the streaming functionality really resides. A lot of it is about the data grid, and then they have some particular streaming APIs, and then there's the compute grid, of course, gets used when you're co-locating some of your processing for streaming. But most of you were in here last talk, so I'm not going to talk a whole lot about Ignite. But this is where the streaming functionality is really happening in that context. So I'm going to maybe get down to a little bit of the practical aspects of streaming with Ignite and just talk about how does it really function so that we can then go into the demo and you can understand how that comes together. But essentially, what they've done when you're thinking about Ignite streaming is that they've provided a really high-performance way of putting data into the cache. So the Streamer API is basically a high-performance mechanism to put data into the cache. And that's as simple as it is. And then after that, so that's on the left side here, you're just streaming data into the cache. Then on the other side, now that you have it in the cache, you can do whatever you want, right? You can manipulate the cache with expiration policies or eviction policies, and then you can do SQL queries, continuous queries, anything that you want, right? Now it's just a cache at that point, and you can do anything you want with it. The cool thing about it is that you bring everything that Apache Ignite has, scalability, fault tolerance, the high throughput, and of course the speed of those, the low latency, right, on these queries. All that comes in for free, if you will, right? Because this is, you're backed by the entire Apache Ignite platform. And the other thing is that if you think about everything else that you have in Apache Ignite, now you kind of have this convergent, let's say, data platform where you have the ability of using all the different pieces of that puzzle within your application, and this is just another piece. So that it's good, in terms of I have one set of infrastructure that can service a whole bunch of my needs. So just a little bit deeper into the Ignite data streamer. So this is a particular API. It's a class, right? The Ignite data streamer, and it can connect. There's some implementations that allow you to connect to Camel, Kafka, MQTT, JMS, and there's some other ones. There's even a Twitter one if you want to do that. It's like the canonical example, right? So Camel, if you're not familiar, it's an ESB. So it's just like one word there, but it allows you to connect to just about anything. I mean, you could connect to MQTT through Camel if you wanted to do it that way. You can connect to an FTP site. You could look at file systems. So because it's an ESB, it lets you do, it's kind of provides a whole other set of integrations that they didn't have to implement a custom streamer class for because Camel provides those on its own. Kafka, you guys are all familiar with, messaging, PubSub, very popular. MQTT, for people that are in vehicle telematics or IoT and sensors, MQTT is a good one to have. And then JMS, And so this allows you to connect to any of those data sources, and then it just uses the same API. The Ignite Data Streamer API is what gets used to add data into the cache. And they also provide a couple of hooks that allow you to do something with that data before you put it in the cache. And it is just, it's a receiver, the Stream Receiver API, so you get this one hook that you could add. So whenever I'm going to put something in the cache, I could say, I want to add a stream transformer, and what that's going to let me do is maybe update a count value. So instead of just adding new events over and over to the cache, I could say, well, I want to count the number of times I saw X word, or I want to count the number of temperatures over 100 degrees, the number of times I saw that temperature. So you could do different manipulations like that. The stream visitor is just basically I want to look at everything that's coming in and do something particular, anything with it. I'm going to look at every event as it comes in, and I'm going to write some code that transforms it, that changes a different cache. And in fact, so the way the stream receiver, it exposes a little bit of the API here more, in that the nuts and bolts is, again, that it's just a high-performance way of putting data into the cache. That's all it is. So in fact, when you are using the stream receiver APIs, you're circumventing the common Ignite streamer add to the cache whenever you put an event in. And what that means is that you have to manually put it into the cache, right? So in a stream transformer function, if you're using that class, you do your transformation, and then you say put into the cache, okay? So if you weren't using the stream transformer, in the Ignite data streamer, you would just say add data, and that's making the call put into the cache for you. But because essentially when you give an API, I don't know what you want to do in the transformation, so I'm not going to automatically add that piece of data into the cache for you. You transform it, and now it's up to you if you want to put it in the cache. And in fact, you could just circumvent that idea and not put it in the cache. You could fork it and put it into 2 different caches. So there's a lot of flexibility there, but now you're getting kind of into the nuts and bolts of the implementation, and more flexible, but more work at the same time. All right, so the basic building block we talked about in that center, the Ignite Data Streamer API, scalable, fault tolerant. You get all this stuff for free, I guess, from the Ignite framework. At least once guarantee. So these are the semantics of the messaging. So you could get duplicates in there. So you need whatever your processing is for your query, if you have a continuous query running, whatever's going on, you need to be aware that you could get duplicate data. And then the other thing is that there's actually some buffers and batch writing of the data within the Streamer API. So it's not for every event that I put in, it doesn't necessarily make a call out to add that to the cache. It's going to do that based off of a buffer size that you provide to it, as well as a flush frequency. So you could say, I want the buffer size to be 1. That means every time I'm going to make a call. Or you could adjust the flush frequency and say, I want every second, I want there to be flush whatever's in this local cache out to the nodes every second, or every 10 seconds, whatever you want. So that's, I guess, a common pitfall is that you might not see data coming into your back-end cache, so what's going on? Or it's not refreshing as quickly as the events are coming in. You want to update those to reflect what you need in your stream. So I talked a little bit about the Stream Receiver API. It's basically custom processing. It is co-located onto the node, so you're not doing that processing within the thread before it gets added. This is actually, you're pushing it out. Co-located processing, you're using the compute grid, right? That piece of the puzzle. I mentioned that it doesn't put data into the cache automatically. You need to handle that during your processing. And there's a single receiver per Streamer API, so it's not like you're going to chain a whole lot of things into this pipeline. So it's not really a pipeline type of concept there. You've got the streamer API with one receiver that could do a transformation for you, and then that goes into the cache. So that's it's different from what you would expect from like Spark or Flink or something like that, okay? There's a couple of out-of-the-box implementations of that API, which we talked about a little bit. And then if you look at these articles, which I really think you'd benefit from, in these stream receiver APIs, there's a possibility of implementing some of these semantics of watermarks, triggers, accumulation. Another place where you could implement those ideas, those design patterns, would be in continuous queries. But what a watermark is essentially, I know as of whatever time it is right now, 12:10, I'm just going to pick a time. I know that I've received every event that I'm going to receive up to 12:10, so then I'm going to trigger an event, something to happen. So I can process my data based off of some knowledge that I have a complete data set right now. A trigger could be, well, I want to make sure that I do something once a minute or once a second, and I want to do a particular processing. And then accumulation is more suited to doing cache expiry policies. You could implement those patterns. But accumulation is, should I keep all my data? Should I discard it once I've understood the results and I have the results? Or should I change the previous result based on my current data set that's been ingested? Sorry for this thing that keeps popping up, guys. I guess I need to update something on my computer. All right, so one of the big things that we're always thinking about when we're doing streaming, because it's an unbounded data set, is windowing. Right? So you could have different kinds of windows. You can have a fixed window, that it's just either fixed by time or by size. You could have a sliding window that moves. So if I want to have like a moving average, or every a minute's worth of data, then I'm going to calculate an average over, and then as that moves out of the cache, it's sliding through that. Or you could have session-based. It's another concept. So let's say it could be a web session, right? That could be a window of time wherein you started using a website, and then there was a gap, meaning we can understand that you stopped using the website for 10 minutes, and that's good enough for us to say, this was a session of web usage for this particular person, right? So fixed windows, sliding windows, and sessions. And so when you're doing sliding windows, for example, you can use the expiry policies within the cache to emulate or to build that particular notion of a stream. And let me back up one thing. So if you're going to, there's a notion of the time when the event happened, the time when the event showed up in my cache, and then the time where I actually processed that and did some calculation, right? So there's the event time, the ingestion time, the processing time. And those are all important things to distinguish, because if I have a sensor, if I have a car that's driving down the road and it's transmitting data to me over a cell network and it goes out of coverage, and then 5 minutes later it starts sending me data again, well, what am I supposed to do with that if I want to know something about the event when it occurred versus it showed up 5 minutes later? It could show up in vehicles, it could show up hours later. Well, what do? Do I care anymore? Do I just throw it out? Do I try to update an old result? So these are really important semantics. And in some of the simplest expiry policies that you can have is this created expiry policy. It's already there for you, and you can use it, but it's based on ingestion time, right? So I would say that it's maybe important to create a custom expiry policy that's based on event time if your data has event time in it. So just a couple of pointers, I guess, to think about those three things. And if you go and read those articles that I pointed out to you, they talk about these in length: event time, ingestion time, processing time. and that you really want to do your work on event time. You may have triggers. We talked about triggers a little bit that are based off of processing time. So every minute I want to do something. So keep those in mind, especially as you're developing these with Ignite. So, all right, so querying. It's just another cache, right? I really want to point that out. So once you've got the data in, it's just another cache. And so all the indexing capabilities, all the different types of queries that you can do are available to you. Cross joins, cross cache joins, all that stuff is there. And as I noted with previously, using these continuous queries, you could use that to implement this semantic of watermarks, triggers, and accumulation patterns, and get. So the continuous query, if you're not familiar with it, is basically putting a query onto the node that gets run every so often, periodically for you, is going to kick back an event, and you'll be able to get notified when that query produces some sort of result that you're interested in. So not only is it a way for you to push processing and compute out to the grid itself, but it's also a common complex event processing method where you can just get notified when your event is triggered. All right? So let's do some code. So this is just a really simple use case. Let's say we have a manufacturing line, and we want to monitor the production on that line. This is by no means a real, thing necessarily. I just wanted to bring something that kind of made sense. And so let's say the sensors are streaming the number of items per second through our Ignite data streamer. That goes into our cache. We're putting a window onto that cache so that the data is retained for 60 seconds. And then just for making this demo a little bit interesting, the dashboard is going to show the number of items per minute. So we're going to aggregate that whole window, and you're going to see how things are sliding through this window. It's going to be a sliding window type of semantic here. All right, so I'm going to exit out of that. Had some screenshots here just in case I had to fall back. So I'm going to exit out of that, and I'm going to bring up an IDE here. So the first thing I'm going to do is we'll bring up this here. So if you're doing development, running the H2 debug console is good. So if you set this environment variable, that's set. Then let's see, there we go. So then I'll just run a node in server mode, and that should come up here. And it automatically pops up this console for you, so you can see the data coming through. You can see what your stream is putting into the cache, so it's really useful. All right, so I'm a Spring guy. I like Spring Boot, just like the Target guys. So this is a Spring Boot application. And let me just open the POM really quick. I'm going to go to I want to show you how simple it is to set this all up. There's really nothing to do except add a few Ignite dependencies. So I've got the core dependency, Ignite Spring, although I'm not using it really in here. That would be for XML-based configuration of Ignite, and then indexing. Actually, I think the Spring is being used. So these are the three dependencies, and then once you have those, everything kind of shakes out on its own. Because I'm using Spring, I don't know if you guys care about this, but I'll tell you just in case you got into this. Because I'm using Spring Boot, and it also has H2 dependencies, I had to do a little exclusions of those dependencies and then a specific add of H2 to make sure that the versioning works, because Ignite only works with Ignite 1.5.0 final works with this version of H2. So that's just something to be conscious of. And then I have an event that I'm using. This way, wrong one. So I have a particular event that I'm running, and this is what's going to come into the cache here. So we have made it really simple. Let's say you have multiple production lines, all running at once. So we have an ID for that line. We've got the time of the event, and then the number of items that it detected. Let's say this is a sensor that just can see how many items are passing by, and it says in this second I saw X amount of items, okay? So we talked about this a little bit, right? So this is event time, and this would be important if you want to actually do processing based off of event time versus just whenever something showed up in the cache. Annotations, this, just adding this is going to make it queryable, indexed within Apache Ignite. So then I'll be able to see it as a column, essentially, in my table, and I can just run straight up SQL over it. All right, so that's the event that's going to be produced. And then there's a cache. So this cache is going to be set up on two ends. One, we're going to have the streamers that are sending in the data. They need to know about this cache. So they're going to either get or create the cache. And then the dashboard side of it, which I'm going to show you, also needs to know about this cache, and it's going to connect to that. And so it also needs to get or create this cache. So it's all here in this class, so both of them can access the cache configuration. And here's our production line event. That's what we're setting as the value. So key value. And right here, this is just a really simple setup to do a sliding window of 60 seconds. And this is based off of ingestion time, really, right? So whenever it shows up in the cache, it's going to keep 60 seconds worth of data, and then it's going to dump everything else out, right? So we're discarding everything. We're only keeping 60 seconds of data. If you wanted to keep all the data but also run a sliding window, then you would want to go to different caches, right? So you have a cache that's just running a sliding window of 60 seconds, and then I want to keep all the data so I can process an entire day's worth and understand what was going on for that day. Then I need to run that through a different cache. All right? So I'm going to show you the stream. We'll bring that up really quick here. So we set this client mode, so you'll be able to, so this guy's not going to run as a server. He's just going to run as a client, okay? Very simple, using the standard Ignite example configuration XMLs. You don't need anything else for this. Then the cache config that I showed you is used right here. We get or create that cache, all right? And then we get a data streamer API instance. And for this case, so that we can just see all the data coming in, I talked about the buffer size and then the flush frequency. I just set a buffer size of 1, so it's all running over here. It's fine. Every event is just going to go straight into the cache, and it's not going to buffer anything on the client side. All right? And then I just set up, just randomly send some numbers for the number of items, just so that we have something interesting to look at. Okay? So I'm going to go ahead and run this. I got 3 of them kind of preset here. So I'm going to kick this guy off. All right, so there it goes. Hey, new version is available at Ignite. I think Nikita just mentioned that in his last talk, so there you go, in case you were wondering. So you can see here that servers 1, which is this guy, clients 1. So we've got a client, and he's running some data through here. And then I can go back to my console, refresh this, and there I have production lines cache. Within that, I have a production line event. I can run this, and you can see the key, you can see the value, which is the serialized class, and then here's my indexed columns that I can query off of. So it looks just like a table, and this is really useful to be able to debug and make sure that you're seeing what you're expecting to see there. All right, so that's running. So I have I'll bring this up just for good times. We got this production line monitoring application, which is just a Spring Boot application. I love it. You can just put this annotation on there, and it does everything else for you practically. Because it's a Spring application, I do have this cache being set up as a bean, and then I can inject that bean into any of my other classes. So this is a web application, right? And so it's going to kick off. It's going to create this bean, which is going to be the connection to the cache for me. And then I'm going to use that, so that gets wired in here. So this controller is a REST controller. So that I'm going to show you a dashboard, just a simple web page, right, that is making queries to this REST controller to get the number of items over the last 60 seconds per line. So Spring automatically sets this up for you. It wires in the cache, so I have a way to access the cache within my controller. I have a mapping, so this is the URL, the REST URL that's going to be used. And then here's the query. So we're just selecting line IDs, summing up the number of items. So the way that I put this demo together is that it's sending a data once per second, and I wanted to count up the items per minute. So that's a simple sum. You know, I could do an average. You could set up the cache differently. You could do whatever you wanted. And we're grouping it by line ID and then ordering it by line ID so the web page looks pretty. And that's it. And then I have a simple class that I'm sending back as the data, which if you're familiar with Spring, it translates it automatically into JSON for you. So I get JSON data on my web page. And I'm going to quickly show you here. There's nothing. This is just a simple page with jQuery to run a query back to the production summary URL. So it's going to go hit that URL. I'll get a total per minute. I get a return back in JSON that I'm parsing here and creating a simple table. And then I'm coloring it, just for fun here so that we can see some statuses, maybe kind of simulate an actual dashboard. All right, so I'm going to kick this off right here. It's a Spring Boot application, so it's going to run. And it brings up the Ignite. You can see Ignite client kicking off here. Here's the rest of the Spring Boot setup. All right. And here we go. All right, so really simple, right? We've got one line. I just set some arbitrary numbers for what was green and what wasn't. The total is adding up all three production lines, and it's expecting more than 600 and something to be green. So what I'm going to do is that I'll kick off another one here. And because of the query that we're doing, it's going to automatically pick that up over here. Now here's where you can see the effect of the sliding window, right? So we're looking at a 60-second time period. And because I just started this production line 2, it's starting to increase its number, right? It's going to stabilize eventually once that sliding window gets filled up with the whole 60 seconds of data. And then it'll kind of stay at I don't know what I set for the random numbers, but somewhere around 500, 600 something. And then the bottom total, starts changing. I'm going to do the same thing. I'll just add one more I've got 3 here configured already. So, this also highlights that with the querying, so I didn't make this a continuous query. It's more of it's not an Ignite continuous query. I'm just polling the data and getting it out. But this could be a continuous query that's giving you events for when a new line comes up and telling you what's going on with each line. In my case, because of the queries that we're doing, it's really easy to detect, okay, now I have more lines in the picture, and I can just automatically add that to the dashboard display. And then if so line 3 is still coming up, and then you'll see, I'm going to terminate, I'll just terminate this guy. And then it'll start decreasing. So that's the effect of the sliding window. Now that sliding data is sliding out of the window, and you can see line 1 is going down in its total as that data slides out of the window. So that's it, really simple. What I wanted to do today is just give you an overview of what Ignite can do with streaming, how it works, getting data in, how you can use the cache and do queries, and then just really dive into some code, so hopefully it's real for you. Okay, this is how it works, and you understand how you can take this back and do something with it, understand the limitations a little bit, and understand the benefits as well. So hopefully I've been able to do that. I'll open it up if there's any questions right now from anyone. Yeah?
You know, it says at least once, but if you use batching, if your client dies, it gets lost.
No, I don't think.
The batch window is not reached. Let's say I have 100 and 50 in it. This client gets killed.
If it dies, yeah. You know, I'm not sure if what they have set up there. Yeah, sorry. The question was, it has at least once semantics, but if the client dies and it has a buffer of 100, and do you lose that 100? And I don't know. I'd have to look it up. I remember reading that it does not, that it will persist that. It's fault tolerant. It'll get that data back in, but I'm not 100% sure. So I'd have to check it out. Other question somewhere? Yeah.
Did you say the streamer receivers are in the fabric, or are those client side?
Yeah, they're co-located within the fabric. Yeah. Anything else? All right. Well, thank you very much for your time today. Really appreciate it.